Hi, I'm Caleb Scharf, and I'm Director of Astrobiology at Columbia University in New York. And I'm really excited to be invited to participate in this 100th anniversary of the Great Debate. So the question is, how will extraterrestrial life first be discovered? Well, I like to think about this slightly differently with the question of, will we recognize life when we see it? Because to me, that is as important as the technique that will be successful for us, and it will actually help inform us what that technique is going to be. To think about this a little further, let me throw up the following graphic. It's a strange looking graphic. I have believable on the y-axis and informative on the x-axis. These are referring to the nature of the information that we may be able to gather about life elsewhere in the universe, or the possibility of life elsewhere in the universe. And to explain it further, let me start with an example of the solar system. So in the solar system, we can go to places like Mars. We can go to places in principle like Enceladus and Europa, the icy moons of the giant planets, in our quest to find evidence of life that is either there today and active, or life that has been there in the past. Now, our solar system is an incredible resource for searching for extraterrestrial life. But there are certain things about it that we have to be clear about. So for instance, I've plotted here that the data we might obtain about life in our solar system is high on the believable scale. So it's above the dashed line, it's high on the believable scale. And part of that is that we can go and we can confirm our discoveries. We can go to Mars and study Mars in exquisite detail. We can go to the icy moons and study them in exquisite detail. We might even be lucky enough to capture some organism and look at it under our microscope. So the data is good. The possibility of doing full scientific analysis on extraterrestrial life in our solar system is really high. But is it so informative? On the grander scale, it's not clear it is as informative as other forms of extraterrestrial life. Maybe life in our solar system is all related. Or maybe what we'll learn is that just life in our solar system is somehow connected to certain unique qualities of our solar system. So it may not be as informative as we would hope. But if we move to worlds around other stars, exoplanets, for instance, I think it's easy to argue that that discovery, the discovery of evidence of life on planets around other stars, would be far more informative. It would tell us that life can spring up entirely independently of the one example we have here, and it would broaden the potential landscape for life. It would broaden the range of environments that we might find life on, and so on. But is the data as believable? It may be for a long time that our information about potential life on exoplanets is in the form of quite rudimentary data on so-called biosignatures. So for instance, sensing the chemical mixtures in the atmospheres of rocky planets that have temperate environments, all of which would be remarkable, but it may take us a long time to argue the case that what we're seeing is really due to the presence of life and not other phenomena, other natural processes. So I would rank this a little bit lower in the believability scale. But of course, at the other end, at the extreme in terms of informative data would be technosignatures. So this is the modern terminology that we use to talk about SETI, the search for extraterrestrial intelligence. It could be radio signals, it could be laser beamed signals, it could be also structures and changes to the natural environment that have clearly been perpetrated by a sentient species, by cognition, by agency. So it could be a variety of strange phenomena that we see in otherwise normal astrophysical data of stars, of planets, and other things. But technosignatures, if we successfully identified some, would be remarkably informative. Perhaps the most informative evidence for life elsewhere in the universe. It would tell us about the level of sentience of life, its cognitive abilities, and so on. But as I've shown here, how believable would that data be? I think it's a very, very high bar for us to make that data believable. And there is the potential that technologically sophisticated species elsewhere in the universe are so sophisticated that we really don't recognize them, that we don't understand what we're seeing. So to conclude, My best bet is that we may find extraterrestrial life through an accumulation of evidence. Before we're actually lucky enough for an example to sort of land in our lab, we may find piecemeal evidence here in our solar system, in the atmospheres of exoplanets, and conceivably in strange phenomena that might be best explained through the phenomena of technosignatures. In other words, I think before we find that single smoking gun example, we're going to have evidence that life is at large in the cosmos. Maybe it is evidence from biosignatures changing the environment of exoplanets in systematic ways that we can't really probe any further because we're simply too far away and our data is too rudimentary. So evidence that life is at large in the cosmos, even if its precise nature eludes us, I think that's where we're going to be first.